Okay, so let's continue. So last time I forgot to mention as much as we induce a new variable, namely the B field. Okay, so actually the SI unit is important. So for the B field, the SI unit is Tesla. Okay, Tesla. Yes, actually the brand name you are familiar with, Tesla. So actually, Tesla was a physician. Was a physician to invent the AC, okay, the alternating current， 交流电它是他发明的。那直流电的话是爱迪生嘛，那交流电的话是 Tesla 啊 ，Tesla 啊，我们也会戏称他为雷神雷神。Okay, so here we slightly talk about the cross product, comparing with the dot product. So for the cross product, the physical meaning is something like this. Okay, so suppose we would like to calculate a V cross B. Okay, so actually this is the magnitude. Okay, so if we have V and B, okay, so if they are crossed together, so according to right hand rule, okay, you use your forefinger pointing to the direction of V and then you cross to B. Okay, so this is the phi which is less than 180 degree. Okay, so you use your forefinger pointing to this direction and then cross to the B field direction, and then your thumb is pointing out of the page. Okay, pointing out of the page. We will use this, okay, a circle with a dot to demonstrate that this vector is pointing out of the page. Okay, so this is V cross B and it is out of the page. Out of the page. If a vector is pointing into the page, we will use a notation like this, a circle with a cross. Okay, so this means the vector is pointing into the page. Okay, 就指向里面还是指向纸的外面啊？ Okay, so this is the direction. Okay, this is the direction actually pointing out of the page, and the magnitude will be something like this. Okay, you try to use this side and this side to draw a parallelogram. Okay, 就是一个平行四边形啊。Okay, so this area is actually the magnitude of V cross B. V cross B. Okay, why? Easy proof is like, suppose we have a triangle. In high school trigonometry, the area of a single triangle is actually 1/2 V times B times sine of phi. Okay, so according to the high school trigonometry, okay, or known as theorem of sine, theorem of sine 正弦定理了 ，OK， 就是这个三角形的面积说平行四边形是它2倍 ，so this is actually VB times sine of phi is actually the area of the parallelogram. Okay, so this is the geometrical meaning of the cross product. Geometrical meaning 就是那个几何的意义。Okay, if it is a dot product, if we have now A dot B to be A times B cosine of theta, so it will be like A. If we have A and B, okay, so this will be like. So we try to draw a line which is perpendicular to this. Okay, and then so this one will be P cosine of phi. Okay, so the projection of B on A multiplied by A. Okay, so this is the product of these two. The product of these two. Actually, the projection, or maybe you can somehow like projecting like this. Okay, so this one will be like A cosine of theta. Okay, then the same thing. Okay, and then this is B. Okay, so the projection multiplied by the original vector. I mean the original magnitude of the other vector. Okay, so besides, I also like to mention that if we would like to use the univector notation to calculate the cross product, it will be like something like this. Okay, if we have v to be vx and then I hat plus vy j hat plus v z k hat. Okay, so this is the univector notation for the vector v, and then for the b is a bx, and then I hat plus a by j hat plus bz k hat. Okay, so the univector notation for b vector. Okay, so v cross b will be a determinant of a matrix. The matrix will be like I hat, j hat, and then k hat, something like this. And then we try to write vx, vy, vz, and then bx, by, bz. Very easy to remember. Very easy to remember. Okay, so you just have the first vector and then the second vector. Okay, so in the first row, this is the first row, horizontally is row and then vertically is column. OK， 横的是叫做 row， 竖的叫做 column。OK， 我也不知道行跟列到底哪一个是哪一个，因为不同地方的行跟列，它有些是说直的，有些是横的，所以我一律是说英文就不会搞错，就是横的是 row， 直的是 column。OK， so for the first row, we write I hat, j hat, k hat, and then for the second row, we have the xyz component of the first vector. Okay, vx, vy, vz. Okay, and then for the third row, we have bx, by, bz, which is the xyz component for the second vector. Okay, so this is the determinant of a matrix, of a 3 times 3 matrix. But how do we calculate this matrix? Okay, so the idea is like, okay, so I think for hand calculation you should be able to calculate 2 times 2 or 3 times 3. For 4 times 4, the rules are a little bit different. Actually, generally speaking, for n times n determinant of a matrix, for n times n determinant, okay, there will be n factorial terms. Okay, n 阶乘那么多个项，那么多项，就是如果是3乘3的话有6项，4乘4有24项，所以是规律上不一样的。但是3乘3有一个比较容易记忆的方式。So for 3 times 3, there is a simple rule. Okay, so you try to draw something like this. Okay, this is the first one, the second one, and the third one. Okay, so all of them have 3. Okay, maybe I use 3 different color. Okay, sorry. Maybe I use. Okay, like this. Okay, IJK. So this is the first, and then for the second one, maybe I use this color. Okay, the second one, and then for the third one, green. Okay, this is the 1, 2, 3. Okay, so these 3 we have positive value. Okay, which means for the orange one we have v, y, b, z, and then I hat. Okay, I just put the unit vector at the end for each terms. So this is the first one, and then for the second one, let's say this pink one. Okay, so VZBX, okay, plus VZ BX, and then J hat, and then next the green one. Okay, the VX by and then k hat. Okay, so we still have 3 more terms. Okay, so let's see what color do I choose. Okay, maybe the yellow. Okay, the yellow. This is one. Okay, and then this one, this another pink, this one, and then also purple. Okay, purple, this one. Okay, something like this. Okay, so here you can see, okay, I had, okay, maybe I put this pink, okay, at the front. Okay, I had, and then VZBY. Okay, which means we have a VZBY, and then I had. Okay, but for these 3, we have negative sign. We have negative sign. Okay, so this is a negative VZBY, and then I had. And then the J, okay, we have a VXBZ, and then J hat. Okay, and then finally K hat, VYBX. Okay, K hat, something like this. Okay, so maybe I put this n times n here, n times n determinant. Okay, we have n factorial terms. Okay, so for 4 times 4, you cannot use this rule. Okay, it has altogether 24 combinations. So, but it will be. Yeah, I don't think you will try to calculate by hand for a 4 times 4 determinant. So this rule is okay up to 3 times 3. For 2 times 2, it is even more easier. Okay, suppose we have a B, C, D like this. Okay, so the determinant of a 2 times 2 matrix will be simply as AD minus BC. Okay, so this is a 2 times 2 case. 2 factorial is 2. So this is 2 times 2, this is 3 times 3. Maybe we can a little bit correct the terms. So we have VYBZ minus VZBY, and then I hat, and then plus VZBX minus VXBZ, and then J hat, and then plus VXBY minus VYBX, okay, VYBX K hat. Okay, just collect this 2 term here, 2 term here, and 2 term here. Okay, actually you can see there is there's some pattern here. Okay, so actually this I hat is X. This I hat is X. So you can see this is YZZY, okay, but here with a negative sign. This J is Y, okay, so here we have a ZX and XZ, okay, and then also for K hat, okay, will be K hat is actually Z dimension, okay, so here we have XY and YX, XY and YX. So which means if we have a letter here, we don't have that letter in the front, something like this. 就是 I J K 就是各自是 X Y Z dimension 嘛，所以前面那个就没有它。这个是 X I 就是 X 这里就没有 X。J 是 Y， 这里就没有 Y 这个 K 是 Z， 这里就没有 Z。Okay。Also, I need to mention a little bit more about how to calculate the cross product for the unit vector. Okay. So how to calculate the unit vector? Okay, so if you still remember, for the dot product, for the top dot product, we have something like I dot I equals 1, J dot J equals 1, and then K dot K equals 1. And then for others, for all the others, 0, 0, 0, 0, 0. Oh, I don't try to complete, but you can somehow see like I dot J is 0, I dot K is 0. This one is like J dot K is 0. Okay, so this is just swapping these three, okay, to be here. Okay, so these are the unit vector. I mean the dot product for the unit vector notation. Okay, so here, how about the cross product? For the cross product, we have I cross I, okay, I cross J, and then J cross K, and then we have J cross I, and then J cross J, J cross J, and then K cross K here, cross K here, and then also we have a J cross K, and then K cross I, and then K cross J. Okay, something like this. We altogether have 9 combinations. Okay, so for the most easier case is actually here, here, and here. Okay, if a unit vector dotted with itself, it is 0 vector. It is 0 vector. So it is easy to imagine because we have a sign of phi here. Okay, so if these two vectors are the same, so this phi will be 0. Sign of 0 is 0. So you can simply expect that I cross I equals J cross J equals K cross K to be 0 vector. Okay, so for the remaining stuff, I cross J will be K, and then J cross K will be I, and then K cross I will be J. Okay, so these three, I just use the blue color. And then finally, we have the green color here. So J cross K, sorry, this one should be I here. This one should be I here. Okay, so I, J, K. Okay, I, J, K. Yes, it should be like this. Okay, so here, I cross K should be negative J. And then here, J cross I should be negative K. And then K cross J should be negative I. Okay. So yeah, so actually there is still a pattern here. The idea is like IJK is a sequence. So if you go forward, it is positive. If you go backward, it is negative. What does it mean? What does it mean? You can also use another graph to simplify it. Okay, you don't necessarily need to write out all this. Okay, so here we try to write I, J, K hat here. If we have if we have clockwise, okay, which means from I to J, I cross J will be positive, J cross K will be positive, K cross I will be positive. Okay, I cross J will become K, J cross K will become I, K cross J will become K cross I will become J. Okay, if you just go clockwise, then it will be positive. Okay, it is actually this case. When I cross J will be K, I cross J will be K. Okay, this one J cross K will be I, J cross K will be I, and then K cross I will be J, K cross I will be J. Okay, so for the opposite direction, like this, and like this, okay, will be a negative sign. Will be a negative sign. So for example, here I cross K will have a negative sign, become negative J, like this. And then here, J cross I is counterclockwise, will become negative K, like this. And then K cross J is counterclockwise, become negative I. Okay, so this is the 6 important cases here. And then of course, if it is self-looping, okay, it will be a 0. It will be a 0. If it is looping to itself, it becomes a 0. Okay, so yeah, so this is pretty much about the cross product, dot product and cross product for the unit vector notation. Okay. Okay, so if you need to write out a complete matrix, okay, it would be like this. Okay, for dot product, it becomes a scalar, either 1 or 0 for the Cartesian coordinate unit vector. Okay, for cross product, it becomes another unit vector. Maybe it has a negative sign, or it may be a 0 if a vector is crossed with itself. 就是这样啊，其实是蛮简单的东西。Okay, so next here we slightly talk about the here is the cross product. Okay, for the cross product. Okay, so actually it just mentioned that how to work on the right hand rule. I suppose you should be able to do that. Okay, you just use your order finger pointing to the first vector, and then you swap it to the second one. Okay, just bear in mind that this angle should be between 0 and 180 degree, and then your thumb will be pointing to the V cross B direction. Okay, so V cross B is the so this direction is only the direction of V cross B. Okay, but for the Lorentz force, okay, you must pay attention to the polarity of the charge. If the charge is positive, FB have the same direction as V cross B, but if Q is negative, V cross B will be the opposite direction of FB. Okay, so just pay attention to that. Okay, so for this case, a positive particle. Okay, so FB and V cross B points to the same direction, and then this one negative particle, FB and V cross B point to opposite directions. Okay, it's just that easy. Okay, so here we have a quick checkpoint. So it asks you to determine the direction of the Lorentz force. Okay, the direction of the Lorentz force. Okay, so for the A, okay, for A, okay, V and then B. Okay, so okay, so here this is the positive x-axis, this is the positive y-axis, and then this is the positive z-axis. Okay, so keep in mind that the xyz axis also satisfy the right hand rule. Okay, if you use your finger point to the x-axis direction and then you cross it to the y-axis direction, your thumb will be pointing to the z-axis direction, which is pointing out of the page. Actually, it's like drawing it in a 3D style. Okay, so it is a little bit pointing to the bottom left, but you know the positive z-axis should be pointing to the out of the page direction. Okay, so here if you use your right hand rule to determine what is the direction of the Lorentz force. Okay, so here V cross B, and then this one is a positive charge. Okay, so which direction is the Lorentz force? Okay, so first we use our forefinger pointing to the left side and then cross it to the downward. Okay, so our thumb is pointing out of the page, and then it is a positive charge. Okay, so FB is actually pointing to positive z axis. Okay, will be the direction of FB. Okay, so first we try to use right hand rule. Okay, to familiar with the right hand rule. Okay, so for the second case, V is pointing downward, B is pointing into the page, and then this is a negative charge. Okay, so here we try to use our finger pointing downward. Okay, V is pointing downward, and then here V is here, Okay, V pointing backward, and then B is pointing into the page. So crossing it like this, so your thumb is pointing to the right side, okay, with the positive x-axis. But this is a negative charge, so FB should be pointing to the left side, which is the negative x-axis. Negative x-axis, right. Okay, so for the final one, okay, V and B points to opposite direction, which means the angle between them is 180 degree. Sine of 180 degree is 0, so this is nothing but a zero vector with no direction. Okay, so here we try to use right-hand rule to determine the answer. Actually, we can also use the unit vector notation to do that. Okay, so here let's try for the question A. Vx, okay, V vector is actually point to the negative x-axis. Okay, so we may write it as negative Vx I hat. Okay, I just make sure all these variables are positive, or at least non-negative, so that will be easy to see the polarity. Otherwise, if you just assume Vx to be a negative value, then you just create a problem for yourself. Okay, so for the B is pointing to the negative y-axis. Negative B. Maybe I just need to write it as a negative V, okay, or negative B, and then J hat is enough, because it altogether points to a these two all the vectors are parallel to one of the axes. Okay, so we don't need to write Vx, Vy, Vz. Okay, I just need to put it as a negative V or negative B. Okay. So the only thing we need to care about is this is the negative x-axis. So we have a negative I hat. Okay, so this one negative y-axis, negative j hat. Okay, so here for this one, FB for A, FB equals Q times V cross B. Okay, so we put all the things here. Q is positive, and then here we have negative V, and then I hat, and then cross with negative B J hat, something like this. So so we have one negative side, two negative side. Okay, so it turns out to be QVB, and then we have this one I cross J, IJK. Okay, so we have a I cross J to be positive K. I cross J to be positive K. Okay, so this one you can clearly see that this direction is a positive Z axis. Okay, so this is the first case. And then for the second one, we may also try to do the similar thing. Okay, so for the V vector is a negative Y axis. So negative V IJJ hat, and then B vector will be, this is negative Z, negative B, and then Z is K hat. Okay, for the B part, so it will be FB. Okay, so this is a negative charge, so I put it as a negative Q, and then we have a negative V J hat cross with negative B K hat. Okay, so let's see, we have we have three negative signs, so it is negative QVB, and we have a JK, IJK, JKI. Okay, so it will be positive I. Okay, so here we can see this is a negative x-axis, negative x-axis. So finally, I don't need to write too much. So for this one, V is actually negative y-axis is negative V Yij j hat, and then for B we have a positive y-axis. Okay, will be Bj hat. Okay, so I don't need to write all the thing. You can simply see that we have j hat cross j hat, which will be a 0. So you can simply expect that there will be a 0 vector there. Okay, which means it has no directions. Okay, any question about the unit vector notation? Okay, so here we talk about the magnetic field lines. Okay, so actually it is just similar to the electric field lines. Okay, so it only satisfies 2 points. Yeah, or maybe I should say it is a B field line. Okay, B field line. Okay, so for the B field line, it is just for the direction. It is tangent to the B field line at any point given gives the direction of the B vector at that point. Okay， 也是说这个 B field line B field line 的话就是那个点的话就是切线方向就是它的那一点的 B field 的方向。And then also the spacing of the line represent the magnitude of B. Okay, the or the B field is stronger where the line are closer together, and conversely. Okay, 就是越密的话就是 B field 的越强。OK， 就是像这个的话就是这个部分就是很强外面的话就会很弱外面很弱。Okay, so here is a simple experiment. Okay, here we have a magnetic bar. We have a magnet bar in the middle, and then we try to put many iron fillings. 这是一些铁粉铁粉，就是不是那个铁粉就是真的字面意义的铁粉OK， 它就会沿着这个B field line 沿着这个 B field line。Okay, so yeah, so here we also mentioned the 2 poles, So actually, a primary student already know for magnetic bar it has 2 poles. Okay, so actually it says the closed field line enter one end of magnet and exit the other end. The end of a magnet from which the field line emerge is called the north pole of the magnet. The other end where the field line enter the magnet is called the south pole. OK， 所以跟那个 E field line 蛮类似的，就是 E field line 的话，它一定是从正电荷出来一定在负电荷终结的如果一个图里面只有正电荷，那些线都会跑到无穷远就比如说有一个正电荷在中间，那全部电场线都会跑到无穷远。这个也类似，那只是说正电荷对应到这里叫做北极负电荷对应到叫做南极。OK， 所以问题来了，那 for E field line it has individual positive charge or individual negative charges. But here for the B field, okay, for the magnet, okay, you can never create a monopole. You can never create a monopole. Okay, so for the magnetic monopole does not exist. Okay, if you try to break this magnet bar into 2, it becomes NS and NS. Okay, individually. Okay, if you further break it, it becomes further smaller NS pairs. Okay, but given a single magnet bar, it always has 2 poles. It always has 2 poles. Okay, so this is important. This is important. Okay, so actually it says magnetism in magnet bar and electromagnets is not caused by magnet monopoles. Okay, And indeed, there is no known experiment or experimental evidence that magnetic monopole exists. OK， 所以这个蛮重要的话，就是说电荷我可以拿出一个正电荷，我也可以单独拿出一个负电荷，那它就会有一个单一个极的一个电荷。那当然它也有 dipole 嘛，但是它就是不是最简单的那个层级，最简单可以单独有一个正电荷，可以有一个单独的负电荷。但是磁的话，它一定你这个 dipole magnetic dipole 啊，你怎么拆它都是 dipole。你把一个 dipole 拆成2份，它也是2个 dipole， 2个小的 dipole 啊，再拆更小的 dipole。它没有 magnetic monopole 所以有趣的地方是，如果你还记得高斯定律，高斯定律是什么？E dot dA，OK， epsilon naught 等于 Q enclosed，OK， 所以这个是我有一个 suppose we have a Gaussian surface，OK，if it encloses some charge，OK。So you just add up all the positive, negative charge, and then you see the excess charge within the Gaussian surface. So this value is related to this surface integral. 就是这个高斯定律的右手边就是这个静电荷它有可能是正的，有可能是负的，也有可能是0但是有可能是正，有可能是负，但是如果对于 B field 的话，我们做类似的事情的话，它会类似长这样的 mu0 integration of B dot dA 后面会讲的，32章会讲的，所以现在不知道没关系。那电荷变成磁的话，它一定是 dipole 吗？所以正跟负一定一样所以它变成0。所以这个就是这个磁版本的那个高斯定律32章会讲的Chapter 32， 所以磁场的版本的高斯定律会比较简单，右边一定是0，右边一定是0，你怎么弄它一定是0那个高斯面怎么定义它都一定是0。当然那些物理学家就很无聊的，虽然这个磁单极不存在这个叫做磁单极他们就很无聊。磁单极但是其实他们也会假设说如果这个磁单极存在 Maxwell equation 会变成怎么样呢？它就会跟现在这个不然你还不知道4个式子长怎么样嘛。但是他们也就尝试去确导，如果磁单极存在的话这个会多出来一个什么，或者其他另外2个式子也会多出来一些什么它就会有另外推一些版本可以在这个 Wiki 的看到一些相关的。但是现在的话就是不存在没有一个实验能够找出一个磁单极的存在。Okay, so here we have a sample problem. So let's take a look at it. Okay, so it's simple. So let's finish it before we have a break. So it says a uniform B field with magnitude 1.2 millitesla is directed vertically upward throughout the volume of left chamber. Okay, a proton with kinetic energy 5.3 mega eV. Okay, I don't know if you still remember this unit. This is not a SI unit. This is a unit of energy. Okay, for the SI unit it should be joule. Okay, so between them it has a factor of 1.6 times 10 to the minus 19. Okay, so enters the chamber moving horizontally from south to north. What magnetic deflecting force acting on the proton as it enters the chamber? Okay, the proton mass is this one. They get the Earth's B field. Okay. So here we have B field. Okay, B field. Using this green dot, it means that the B field is pointing out of the page. Even though it don't have a circle, but all this green dot means the B field is pointing out of the page. Okay, so here we also assume that the charge Okay, the charge is moving upward, moving to the left side, Okay, so there will be a FB acting on it. Okay, so V cross B, V is pointing upward. Okay, we use forefinger pointing upward and then crossing out of the page. B field is pointing out of the page. Okay, so pointing to the right side. This is V cross B, and it is a proton, 质子正电荷的. Okay, so actually FB also point to the right side. So here we have FB point to the right side. So here we would like to know what is the velocity, because here we only know the kinetic energy. So we need to find the velocity so that we can plug the velocity in the Lorentz force formula. Okay, so actually K is 1/2 mv squared. So which means it is a 2k over m, and then take the square root for the whole term. So this is 2 times 5.3 times 10 to the 6th power, and then times 1.6 times 10 to minus 19. Okay, so yeah. Okay, so you just need to keep in mind that EV is a very small unit. Okay, so which means if you need to convert EV into joule, you need to multiply by 1.6 times 10 to minus 19 to make the values very small. Okay, and then mass is 1.67 times 10 to negative 27, and then take the square root. So this velocity is 3.2 times 10 to the 7 meter per second. Okay, so the velocity. So FB will be QVB sine of phi. Okay, so we can clearly see that the phi. Okay, I cannot draw it here. The B is pointing out of the page. Actually, the phi is nothing but 90 degrees. So this is 1.6 times 10 to minus 19 is the Q, and then times 3.2 times 10 to the 7th power, and then times B is 1.2 times 10 to negative 3rd. Okay, B Tesla here, and then sine of 90 degree, which is 1 here. Okay, so finally we get FB is 6.1 times 10 to negative 15 Newton. Okay, so this is the force. This is the magnetic deflecting force acting on the proton. So which means at the beginning, the initial velocity is pointing upward, but there is a force acting on this proton pointing to the right side. Okay, so finally the path will be something like this. Okay, 就是有点像那个抛射运动，就平常你如果平射一个物体出去，它受到地心引力会抛物线嘛。那这个也是抛物线，不过是转了90度啊，因为这里是忽略那个gravitational force 啊，或者也忽略那个地球的那个磁场，所以这个是转了90度的抛射运动。Okay, so here it also asks you how large is the acceleration of the proton. Okay, so just make use of the Newton's second law of motion. A equals F over m. Okay, so which is 6.1 times 10 to negative 15 Newton over 1.67 times 10 to negative 27. So this is nothing but 3.7 times 10 to the 12th power meter per second square. Okay, so this is the acceleration. This is the acceleration. So really, really fast. Okay, so this part we cannot see it again because this is a fresh. Okay, so maybe